Okay, hello guys. Good afternoon to everyone, and we're just gonna wait for a few more guys to join us tonight on our third online Saturday sessions. Techph.org, powered by recruitday.com, recruitday.com, and you see here that we have already 4 viewers. And for everyone's information, we're actually streaming live on Facebook and also on YouTube. So don't forget to also subscribe to our YouTube channel. It's TechPH, and follow us on Facebook. So there. And today we have Prince Javier of Bridge 360 will talk to us about data science and also about Project Moses. Okay, so let's just wait for a few more people to join, and we'll be starting in 5 minutes. And just a quick reminder, we will have the video, the recording of this online session available on YouTube and Facebook. And if you want to get the session packs, which will include the references discussed by Prince today and the presentation, please kindly register to the link provided on the description on the video that we're live streaming this afternoon. Yeah, how are you, Prince?
I'm good.
Yeah,
And
it's
everyone.
yeah. If you look outside your window, guys, you can see that it's a bit cloudy. So we're expecting a little bit of rain, and hope everyone's okay. Because I just recently heard that there's an earthquake in Aurora.
Yeah, I felt
Just
that.
yeah, a few hours ago.
Yep.
So I hope everyone's okay. Uh, yeah, so we'll just wait for a few more guys to join us. And again, just to remind everyone, please kindly follow us on Facebook and subscribe to our YouTube channel so that you can access the recording of this content at the end of the session. So we have 23 people who've joined us today, and you can also join. You can also comment your question. So Dario Vallejos ask where do we send our questions. So you can just comment it on either Facebook or YouTube, and then we'll answer it at the end of the session. Yeah. Okay. So we'll just wait for a few more guys to join. We'll start at exactly 5:05, and I already have Prince here ready with this presentation, and we'll answer again. We'll answer all your questions. We'll try to answer all of your questions at the end of the presentation. Yeah, and I think Prince, you have a fan base here. So Jude Michael Teves actually commented, "Go
Hi, Jude.
Prince Javier."
Thanks for
Yeah,
support, Julio.
let's show that comment on the screen so that everyone sees. So any comments, recommendations that you can do for our next session, we'll also be providing a survey link where you can put it there, and we'll try our best to actually find a speaker who can talk about your recommendations, your recommended topics, and for future sessions. And for everyone's information, June is our design and development month. So we'll have tech leaders and professionals who will talk about their respective fields in tech, specifically in design and development. Okay, so we have, I think we have 33 people now who's viewing us this afternoon. Okay. So again, hello guys. Good evening to everyone. I think it's already evening, and thank you for tuning in to TechPH third online Saturday sessions. And this is On You and Emerging Technologies. I'm Luis Barring, your host, and today we are joined by Prince Javier to talk about data science and Project Moses. So he will talk about the information platform a little bit later. And please leave your questions and comments in the comment section on either YouTube or Facebook, and we'll try our best to answer all of your questions. And kindly register to the link in the video description to get the session pack as well. We will try to send that, if not this evening, start of next week. Monday is a holiday, so probably Tuesday, if not tonight. And also a reminder, in our next online Saturday sessions, we are joined by Paulo Espiritu of Araya Learning Innovations and Argelo Royce Bautista. a Microsoft MVP for a data platform. So on May 30, 5 p.m. to 6:30 p.m. So that's session number 4 with Argelo on paginated reports in Power BI. And on May 30, 7 p.m. to 8:30 p.m. with Paulo Espiritu on AR and the future of learning. You can register now in the link provided on our Facebook page. And also, June is Design and Development Month. We have invited speakers with different specializations to share their experience and expertise. So for our first sessions on design and development, we will have introduction to product design, UX fundamentals, and design and development team cycle. And on the next sessions, we have introduction to PWA, developing for Android and iOS with Flutter, Android native development, iOS native development, and introduction to game and game development. Also, we will find a way, since a lot of you guys are requesting for WordPress. We are also looking for a speaker at the moment to talk about WordPress, probably an introduction to that, and that person will walk you through how to create your own website using WordPress. So please continue to visit our page to register to these events. And this session is powered by recruitday.com. Okay, let me just show this to you. Okay, so if kickstart your IT career today by scanning the QR code on the screen, or you can also use the link in the comments. And if you are a fresh grad or a career shifter and you want to pursue a career in IT, recruitday.com can help you find jobs in awesome companies even during this crisis. Just visit the link to apply, and you can also refer your friends and get hired. Get 3,000 pesos for every successful referral. We will post the link to the comment section of this stream. And again, the questions will be answered at the end of the session. So tonight, I have the honor of introducing Prince Javier. So Prince Javier is the co-founder of Bridge 360 and is also a data scientist. We already have 30 people watching us tonight. So let me just talk to Prince a little bit before we start. Hello, Prince. How are you?
Hello. Yep. Good.
Yeah, you're good.
Yep.
Okay, how's life treating you, Prince?
Life. I'm an introvert, so I thrive in
That's
isolation.
right. Yeah, when was the last time you actually went out?
That was March 12th. I think that was the date Duterte announced the lockdown.
Yeah, and then since then you haven't had the chance to actually go out and see what's happening outside.
I just read the news, pero yeah, I haven't really gone outside.
Yeah, I think that's good. At least you're following the rules. So I actually went outside a little bit earlier today,
Mhm.
and I noticed that a lot of people are already very comfortable in going out. Um, Here in my place, I'm in Mandaluyong. A lot of people are still observing social distancing, which is good, but a lot of people are outside.
Mhm.
So uh, I hope that doesn't trigger anything. There's a lot. They're still following social distancing, so I'm hoping that doesn't worsen the situation. But today we will talk about data science and also what data science, the role that data science is playing in fighting the spread of COVID-19. And to help us understand that, we have Prince Javier. Okay, the floor is yours.
All right. Sige. Yeah, just a quick outline of what I'll talk about today. I'll talk about what data science is, some data science frameworks, and components of data science. But we'll focus on modeling. And there's a lot of talk about data science. So if you look at global Google searches, the interest over time goes up. And there's a reason for that because of the value data science can bring, which I'll talk in detail later. But before we talk about data science, we have to talk about what data is, right? Or what are the kinds of data that we have? All right. So here are just some examples of data. You have satellite data. You have um, like spreadsheets, tables, but you also have like books and text data. So those are data as well as photos and videos and audio. So these are just some examples. These are not exhaustive, uh, but it just gives you an idea that data is not necessarily just tables and numbers on a spreadsheet, but they can also be like pictures, photos, videos. Simply speaking, data data are collected or recorded information, and we are swimming in data. Every time you use Google, every time you use like Amazon or Lazada or Shopee, every time you use Facebook, Instagram, you're logging data. So Google is capturing your behavior, uh, as well as like Amazon or Lazada, they're capturing your buying patterns. Facebook, they're able to capture like your political views, right? Your what are your tastes? What are your likes? And with Instagram, if you take photos of where you go, like places you visit, or maybe the food you eat, those information tell a lot about who you are as a person. And so we use these tools almost every day. Okay, so with the advent of the internet, we're getting like tremendous amount of data. And I don't know if you've heard about this, but I keep hearing this: data is the new oil. And you know what? Oil is like it's something in the ground, but if you're able to extract that, and process that, you convert that to fuel that you use to run cars, and that gives value. Okay, so oil in the ground is nothing, but if you're able to extract that, you can get value out of that. And I heard someone said data is the new soil. So just like soil, uh, you can grow plants using soil. So like data, you can grow value. You can come up with data applications and things like that, so you can achieve your goals. But you can also think about it like uranium. So we use uranium to generate electricity using nuclear plants. But we know uranium can also be used to make nuclear bombs. So data, I would say, is just like uranium. It's a double-edged sword. So you can use it for the good or you can use it for the bad. Data can use for the good. Uh, Google, it's a really useful tool to search basically all the knowledge in the world. Um, but you can also use data to come up with new medicines. So right now we're in this COVID quarantine period, and there's a lot of researches going on to find a vaccine or maybe a medicine against COVID, and data is used for that. Like protein data, data about compounds and all these things. Now we can also use data to explore the galaxies and basically explore our universe. So understand how our universe works. You need to have data to be able to do that. But data can also be used for bad. So if you're familiar with Cambridge Analytica, if you heard about them, what they did is they gathered Facebook data. So like all sorts of information about people, um, most notably their political views. And they used these information without people's consent. So Cambridge Analytica basically stole people's informations, and they used these information to come up with political propaganda to sway their votes towards a particular candidate, and we know it's Trump, right? At least in the U.S. Um, so things like build the wall, these are products of data analytics. these memes are products of data analytics. And that's really bad for democracy. If you're able to collect data about people in order to manipulate them or to influence their behavior, that's really bad for democracy. It's basically mind control. Yuval Harari, Oxford historian, said, when you have enough data, you don't need to send soldiers in order to control a country. So this is what he calls a data colony. Why? Like what Cambridge Analytica did, if you have enough data, you might be able to influence people's behaviors, how they think. So that's kind of scary. But like again, like a double-edged sword, like um, uh, you have two sides, something that's bad, something that's good. Uh, data data is practically neutral. It's how you use data that's important. So again, another analogy, it's just like fire. We use fire for a lot of things. It's really useful. We use it to cook food. But at the same time, fire can burn buildings. So data in itself, it's practically just fire. What matters is how you use fire. So how you use data. Right. So just to recap, data, it's collected or recorded information. It could be text, it could be audio, it could be video. As long as you record it or collect it, that's data. And with the advent of the internet and all these applications like Google, Facebook, we're generating a tremendous amount of data that's never been generated before. And data can be used for good or bad. Okay, so that's data. Now let's talk about data science. What is data science? The thing is, there's really no single definition for data science. But if you look at the internet, you'll be able to see, things like these Venn diagrams, which try to visualize the essence of data science. Okay, so let's discuss the first one. Here, it's showing it's a mix of three things. First one is hacking skills, but hacking not in the sense that you're trying to, like hack a website. It's more about coming up with optimized programs or, computer programs. So like, let's just call it programming skills. Programming skills, and then here on the right side, you have like multivariate statistics, or just let's call it statistics. And the intersection of statistics and programming, that's where you can get machine learning. So Bash and Justin, they talked about machine learning in the previous techph webinars. But I'll also discuss a bit about machine learning. And so that's the intersection, programming, statistics. And the third one is domain expertise. So data science in itself is kind of useless without a specific domain. So this could be, a specific field. So it could be an engineering field, it could be a scientific field, it could be some sort of business. So it has to be there. It has to be there. There has to be a problem in a particular domain that can benefit from data science. So this is really important. So if you have domain expertise and you have programming skills, you can get traditional software, and these include like applications, like websites, mobile applications. If you have domain expertise and you mix that with statistics, you get traditional research, statistics without programming, for example. Now the intersection of these three, according to this Venn diagram, that's data science. Okay. All right. So the next Venn diagram shows four things: communication, statistics, programming, and business. So domain expertise, business, they're both here. Hacking skills, programming, statistics here. But there's another one, which is communication. So what it's saying is data scientists must be able to communicate insights, to translate data to action, you have to be able to communicate what insights you got to your they call this to managers or to those who can drive action, to your leaders, basically. So if you're able to mix these all four, it says here you get the perfect data scientist. Okay, um, that's kind of a rare, it's the kind of rare thing, but you must have at least good communication skills. You have some statistics understanding, program business. So data science is a mix of many things, but the definition is still evolving. There's no strict definition, but I hope this gives a sense of what data science is. If I were to summarize this, I would say data science is the field that's about turning data into actionable insights or apps to achieve goals. So that's related to the domain expertise in the business. They have to be there. That's important. Having goals and problems that you have to solve, it has to be there. Okay. Right. For that, just double check. I may be going too fast. So hard to assess since there's really no feedback. But okay, I'll proceed. I'll discuss a bit about this data analytics maturity. So there are four levels of data analytics maturity. The first one, it says here, descriptive analytics. This is really the foundation of it all. Trying to understand what happened in the past. So you got data that came in. You want to understand, like describe it, basically. Describe your data. This is where you see like histograms or your distribution curves, or maybe your mean, your median, your mode, or these are the things that you look like in hindsight. Okay. Now the next step will be trying to diagnose. Um, so we are able to describe the data. Now, why does the data behave this way? That's the next question. So you're like a doctor, you're trying to diagnose a disease, and you're basically trying to answer the question why. And that adds more value from descriptive analytics, because you're able to understand like causality. If you're able to understand causality, you might be able to tweak the drivers, so to speak, of a certain outcome. Okay. Then moving up the ladder, you have predictive analytics. So this is when you no longer look at historical data. You try to predict the future outcomes. You want to see what will happen in the future. So that adds value because that can help you decide what to do. If you can perfectly predict what the future holds, then you can practically win over life. Like if I know what the next lotto numbers will be, I can practically get rich in an instant. So that's the idea. If you're able to predict the future, you can get you can make better decisions. But moving beyond that is prescriptive analytics. And this is when your model or your computer practically just tells you what to do. Okay. So what is an example of that? One example will be Waze, okay, or Google Maps. So let's say I want to go from my location to my destination. It's gonna give me a path. It's basically prescribing a path. So that's prescriptive analytics. Now, organizations should aim to move up the ladder. So if you're an organization that's doing descriptive analytics, like what happened in the past, um, you should strive to move up into diagnostic analytics. And if you're now here in this stage, you should aim to move up, to move forward. Okay. And the reason is you're able to make better decisions the higher you go. Okay. And that's what this value y-axis means. You can get higher value the higher you go in this ladder. But definitely, it becomes more difficult to do that. So for descriptive analytics, There's certain tools that you can use to do that. For diagnostic, you have to infuse there some domain knowledge, some ideas of causality, and all that. For predictive analytics, that's when you do a lot of modeling. You do a lot of programming and hacking skills. For prescriptive, that's another level of modeling. It's basically AI, artificial intelligence, telling you this is what you have to do to solve a particular problem or achieve a certain goal. So organizations should strive to move up the ladder. So if you're like a manager in an organization, try to assess your organization, see where you fall in this ladder, and then try to find ways to move up. Right. Okay. Um, Here's a quick flowchart showing the data science process. So you have data, you collect data, then you have to pass it through the data science process. And I just want to show, if you zoom in data science, it's a lot of things. Like literally, it's the scope is so huge. But to give some examples, you can include like complexity science topics, network science topics, machine learning and modeling, um, and all these things. But the point is, these are a lot of tools that you can use, as long as you get to your insights and action, as long as you're able to add value. So here's another framework for data science. Um, Definitely going back to the idea of the problem, the business goal, it really has to start there. So try to understand your business, try to understand what the problem is, what do you want to achieve, and then you go to understand your data and doing the data science pipeline. So you start with a target, like what is the business goal, what is our organization goal, and then you try to see what data do we have. Do we have existing data that can help solve this problem, or maybe we have to collect more data? So you really have to see. And not only that, you have to see the quality of your data. So are your data of good quality, meaning they're reliable, or are there a lot of issues with your data? So if your data are really bad, you can't possibly come up with a good model. You can't possibly come up with good insights. So, the adage, that's garbage in, garbage out. Okay, so you really have to start with the data. Is your data garbage? Then you have to find a way to fix that. Okay, so once you're able to understand your data, it's good data, it's useful data, then you now prepare your data. By preparing, it means all sorts of transformations. I'm not gonna go like in too much detail, but the idea is you prepare your data. It's like you're cooking a meal. So it's like you just don't put your vegetables into your the container thing that you use to cook. Uh, like you have to cut your vegetables first, right? So if your data are like the vegetables, then you have to prepare your data before you model. So it's like your cooking phase. You have to prepare first before you model, and then you evaluate. So when you're cooking, right, you taste it. Is it good or is it too salty? Okay, so that's when you evaluate the results of your model. And if it's too salty, you go back this process to try to see how you can change probably your data, probably the way you process your data, probably your model, and all these things. Now, if your evaluation is good, so for example, you taste your food, it tastes good, it's nice, then you can now deploy your model. By deploy means the business or the organization or your stakeholder will now be able to use the insights and the model results to drive decision and action. Okay. Um, I hope it's clear so far. Okay, so that's the data science framework in a nutshell. Okay, just gonna drink. Right. Of course, math is the foundation of data science. You can't go around this fact. So if you want to be a data scientist, um, practice math. But math is a huge field. It's the scope of math is huge. So which aspects or which fields of math should you focus on? Here are just some suggestions. Um, Based on my experience, these are the four primary maths that maybe you should focus on first. First, linear algebra or matrices. Um, so how do you transform matrices? Um, how do you add matrices? How do you multiply? How do you divide? And and just try to understand how matrices work, because you will deal with a lot of matrices when you're doing data science. And the next one is differential calculus. This is when you deal with change. For example, changes in people's behavior over time and all these things. And differential calculus and matrices are the foundation of a lot of predictive models. So I keep saying models a lot, but I'll explain what they are later. But these are the foundations. Now, it's also good to study about hypothesis testing, because you do a lot of hypothesis, especially if you want to see causality. Um, your hypothesis is a particular action causes a certain outcome. Okay, there's an action causes an outcome. You want to see if that's true, and you can do hypothesis testing for that. Hypothesis, in a nutshell, hypothesis is a potential explanation for something. Okay, so there's something you want to explain. Okay, if you remember the ladder that I showed you, descriptive, then you have diagnostic. Going to diagnostic analytics, um, you have to pass through some hypothesis testing to be able to see causalities and probability distribution. So thinking in terms of probabilities instead of certainties, it's really useful for data science, especially if you're predicting into the future. The future is probabilistic in a sense that you cannot know for sure what will happen. So if you're doing prescriptive analytics, that means you have already done predictive analytics. And that means you're able to think in terms of probabilities. So these are just the four commonly used math. There are probably a lot more, but these are just, I would think, the four fundamental ones. Right. Okay. Let's start with data visualization, because really when you're at the phase where you're describing historical data, like descriptive analytics, you really have to know data visualization. But data visualization is important for communicating the insights you have to your stakeholders, right? Like no one wants to see a table with numbers, with a lot of numbers, like a table with 1,000 numbers. I don't want to see that. You would like to show that in a visual way, so that it's easy to understand. So it's really true. Like when you say a picture is worth 1,000 words, there's truth in that. If you look at human psychology, people are really able to pick up new things if they're visual. Okay, so let's recap the data science framework. Data visualization is helpful when you're practically from data understanding to um, practically deployment. So that's where data visualization is important. Okay, when you try to understand your data, you want to see distributions, you want to see, are there issues with my data? Um, So for example, if you're looking at data of people's heights, and then there's a data point there that says 100 meters, uh, uh, people cannot possibly be 100 meters high. So that's something that you have to check. And you can easily check that, like more easily check that with data visualization, right? Then when you're doing deployment, in order to in order to make your insights understandable, you have to visualize them. Okay. Right. So data visualization converts raw data into comprehensible and actionable information. Oops. So just to give an example, I got these from New York Times. New York Times is great visuals. Uh, they're really good at making data visualizations. So this is where New York Times is comparing the seasonal flu and the new coronavirus. So if you visualize it this way, you see the impact better, right? Like the difference in propagation is significant. So the new coronavirus isn't really just like the seasonal flu. It's much more contagious. So you get that more emotional impact compared to just looking at numbers. Okay, so this is another one where they visualize the increase in reported cases for the new coronavirus and then compare that with SARS. And it's obvious what this chart is telling us. It's really much more contagious than SARS. Okay, so it has that effect of emphasizing the message. Oops. Right, so this one is about temperature anomalies. Um, so instead of just like giving you numbers of how hot, uh, how like what's the change in temperature, you visualize it this way and you see like, okay, there's a lot of red going on. So it has that emotional impact. And if you've been following the news, the first image of a black hole, this was last year, early last year, I think. So this was not taken by a single telescope. This was taken by a lot of telescopes around the globe, and that and using data and data science, they were able to convert all those telescopes into a single large telescope, considering the rotation of the Earth, the revolution of the Earth around the sun, and all these things. And they came up with the first image of a black hole. So it's still data visualization if you think about it. So what they did was get like hard drives and hard drives of data. And just if you look at these data, these are just numbers, boring numbers like CSV files, Excel files. But with data science, they were able to convert these numbers into an image that we would not otherwise see. So that's the power of data. Now, there's a lot of free and paid data visualization tools. These are just some of them. Um, I'm just showing you guys so you have an idea that you have options. If you want to visualize something, of course you can use Excel, Google Sheets, and all these things, but you also have Tableau, Plotly, D3.js, Shiny, and all these things. Right. Moment. Right. Okay. Here are some data visualization books. I personally read Storytelling with Data and just I just saw business this Harvard Business Review book, and yeah, maybe you can check these out. They got some interesting and useful suggestions how to visualize data. Okay, programming. Remember when I told you that data science involves programming, like hacking skills programming. It's really important because if you're dealing with small data, sure, like you can literally just put it on a spreadsheet and then analyze these data. And it's not going to take a really long time to analyze this data. If you're like dealing with, say, 200 rows, for example, and it's kind of easy to get insight out of that, easier to get insight out of that. However, if you're now dealing with big data, and we're talking about, let's say, millions of rows and hundreds of columns, it becomes harder to get insights um, out of these data. And also, if you want to make data products or applications, or you want to automate analysis, you need machines. So you need machines to deal with big data. It's just impossible and impractical for humans to sift through millions of rows and hundreds of columns. It's just not practical to do that. Good thing we have computers now. And with computers, we can also automate the analytics process and make modeling easier and make data applications. So we can make decisions out of large data sets. Okay. Okay, so what are algorithms? Okay, so when we're talking about computers and programming, we're talking about giving computers instructions how to do something for us. So instead of us manually doing it, we just tell the computer a recipe how to do it. So, for example, in this chart, you're able to see the computer learning to fit a curve, right? From random curves, it's able to learn how to fit it using an evolutionary algorithm, or it's an algorithm inspired by evolution by natural selection. So it's automated. Recap, programming, it's about instructing machines to automate tasks for us. So it's like giving recipes how to cook. So these are some tasks a computer can be instructed to do. You can automate data collection. You can automate cleaning your data. Like, remember when we discussed how important it is to ensure that your data is clean and it's of good quality. And you can use it to visualize. You can use it to describe your data via hypothesis testing, um, uh, describe your data, hypothesis testing, and modeling of systems for prediction. These are just some common programming languages. Python, you have R, but you also have Scala, you have Julia, and there's a lot of programming languages out there. But Python has a huge community. In fact, the image of the black hole I showed you, um, Python played a huge role to generating that image. Right, modeling. Okay. Okay, let's go back to the data science framework. We have modeling after data preparation. So what is modeling? Models are summaries of systems. Okay, in a nutshell, these models are summaries of systems. So you have a real system. Let's say you have the Philippine economy as a system. Now you can come up with a model for that to, let's say, calculate future growth of our economy. Or maybe population, the Philippine population, that's a real system. Now, how do you predict the future population? What you can do is come up with a model or a summary of this system and use that to predict the future population. But I'll explain this further in detail. Okay. This is the anatomy of a model. You have X, which is the empirical data. This is your data. This is the data you find in your real system. These are your pictures. These are your audio. These are your temperature and precipitation, financial data, whatever. F of X, that's our model. So it's a model, it's a summary that then transforms our data, okay, into a target value that ultimately we want to know to solve a business problem. Okay, so this is the summary of our real world system. So it's another analogy will be like a map. So if you have like a map of a place, that map is not the place itself. Otherwise, you won't be able to hold that map. So it's just a summary, it's a compression of a real place that you can hold on your hand. Now you can use that to know where a certain place is. So that's your Y. Okay, so given your X, which is where you are at the moment, you now use your map to find exactly how to get to your destination. And that path to get to your destination, that's why. Right. These are typical models used in data science. Mainly two, regression models and classification models. Regression models deal with numbers. Practically, I want to know um, the future population of a country. You use a regression model. For classification, it's more of categories. Like, do you have COVID or you don't have COVID? So an example of a classification model will be the COVID-19 triage system. So for example, in hospitals, they try to assess whether or not you have COVID and all that, or diagnostic system. Okay, so they try to assess whether or not you have COVID. So they ask questions, they check your vitals, even before you get tested. You check your age, and then they identify, are you a person under monitoring? Are you a person under investigation? So that's a classifier. Now, there are two, like you can categorize models as another way. You can have like explicitly defined models and machine learning models. Explicitly defined models, these are yung what we learn, what we first learn when we study. So if you remember physics, force is equal to mass times acceleration. E equals mc squared from Einstein, or maybe as simple as y is equal to x plus 1, or if-else statements like if you have four legs, you have whiskers, and you say meow, you're a cat. So if-else statements like that are explicitly defined because you clearly know what the components are and how they interact with each other. Now, there's another kind of model which is gaining traction, and these are machine learning models. So, for example, decision trees, neural networks. Machine learning models are models that you don't explicitly code. You don't tell it how to figure out something. It just figures it out on its own via learning from a lot of examples. Okay, so machine learning can be thought of as a subset of artificial intelligence. So artificial intelligence is when your computer is able to do tasks that require intelligence. So machine learning is a subset of that because you can come up with an artificial intelligence that you explicitly code and still it will look intelligent. But machine learning is when you don't explicitly code your machine, but you just tell it, you just share examples. Like you're teaching a child that this fruit is an apple, this fruit is a banana, and it just learns on its own. You don't even tell it if it's red, if it's this shape, it's an apple. You don't say that. With machine learning, you just show, and it learns by itself. Okay, hope that clarifies machine learning. Right. So if you read this, machine learning is when computers improve at a task based on experience without explicit programming. There is a particular kind of machine learning that is powerful, and it's a lot of companies are using this now, and it's called deep learning. So, or neural networks. So neural networks or deep learning, um, that's these are models that are inspired by the human brain or the brain in general. So what happened was scientists analyzed how the brain works, and then they tried to replicate that inside a computer. And now with a lot of data that we have and new techniques, how to simulate real brains in a computer, we're now able to come up with powerful AI. So you remember when I showed the anatomy of a model. So you have x, it goes to f of x, and it goes to y. And f of x in an explicitly defined model is explicitly defined. You just tell it exactly what it is. In the case of machine learning, you don't tell it what it is. You just tell it, this is your prediction, this is the true value, fix yourself, like update yourself. So that's the machine learning model. And machine learning is really powerful, and we're able to come up with applications that would otherwise be impossible without machine learning, in particular deep learning. Self-driving cars are powered by deep learning. Yeah, so this is a quick prototype that I did trying to classify fish. It's powered by deep learning. And you can also use deep learning for power demand forecasting, for example. So so in this kind of example, we wanted to see what will be the future power demand of a particular area. Deep learning can be used, especially this particular model, long short-term memory, um, to not only look at historical data, but also incorporate other data that may help the model predict better. So for example, you can have weather, you can have holidays as input, as well as historical demand. You pre-process that, you train your model, and you can predict future demand better. So it's a powerful forecasting tool as well. Right. Now, digital assistants use deep learning, like Amazon Alexa, you have Siri, you have Google Assistant. So if you use them, there's a lot of deep learning techniques going on in the background. In fact, even Google uses neural networks. So when you type on Google, it seems so simple, but there's powerful AI going on in the background. And because of this AI, they're able to deliver impeccable service. Um, like they really show you the most important websites if you query. Right. Okay. Right. But like going back to the definition of data science, which is you can use whatever tools you have as long as you're able to drive action, come up with insights, to guide decisions. There are other models you can use, like you can have complex systems modeling. Now, this can be useful for certain scenarios. But first, let's discuss what a complex system is. A complex system is it's a system with parts or elements that are interacting with each other, and from that interaction, patterns arise, like behaviors or large patterns arise. So if you look at an ant colony, if you look at a single ant, it's just a single ant. But if you look at an ant colony, you might be able to see interesting patterns. Like here, they're forming a line. Some ant colonies form bridges to get across gaps. So the human society is a complex system. There's a lot of agents interacting with each other. Some have bad intentions, some have good intentions, some have um, certain ideas that um, because of this complex system, we're able to arrive at this kind of society that we have. Trolling can be a result of, it's like an emergent property of the out of this complex system. Facebook is a result of this complex system, and because we had Facebook, it added a layer of complexity, and now we have issues with political polarization and so on. Um, the human body is a complex system. Our brains are complex systems. Anything that has interactions and um, there's outcomes out of those interactions are complex systems. Now, for data science, ideas from complexity science can be useful when you have an understanding of underlying mechanisms of a system. So you can explicitly come up with a formula or a code for a system. So you don't necessarily need to have machine learning. But it's really important if you don't have data to begin with. So if you're trying to predict the future, but you don't have data to train a machine learning model, you can go to this complex systems modeling approach. And it's also useful for scenarios testing. So if you're able to model a real world system in your computer, you can now tweak things. Like, for example, imagine if we have a model of the traffic system of the country. Imagine if you have that. Now, you don't even have to do trial and error anymore. If your model is really good, all you have to do is simulate changes in your policies in a computer first before you even think of implementing them. Right. Now, here's a quick example of a complex system model. It's a predator-prey model. So you have predators, you have preys. This is kind of important to have an understanding, like a high-level understanding of ecosystems, that if you have these number of preys and these number of predators, you have an understanding of like the future numbers of the predators and preys. So it can guide you. It's the thing with complex system. It's not necessarily give you an exact number, but at least it can guide you, like give you the right mental framework to be able to come up with the right decision. So if you're able to see that your predators are going like way up and it's kind of causing an imbalance in the ecosystem, you might be able to do some interventions there. This is another one, and it's so like popular right now because of COVID. You have the susceptible, infected, recovered model, or SIR model. This is a standard model for like understanding the spread of infectious diseases. So this is the curve that we want to see, the number of infected over time. We want this curve to go down. So epidemiologists use this model, and you're able to see the outcomes of your policies using this model. Now, will you be able to use machine learning for here? it may not be easy to use machine learning if it's a new disease or it's a new a new virus, because you don't have data to begin with. You don't have historical data. So these kinds of complex models can help. And if you're really very ambitious, why not simulate the entire universe? So this is one of the most ambitious simulations ever. Like, it took so many months to do this on a supercomputer. You can check this out, Illustricity NG project. So what they did was they fed like the laws of physics into a supercomputer and then just let it run itself. And they're able to see that galaxies did form. And it's really rotating according to it's really rotating according to the laws that they fed in, and it kind of approximates reality. Right. You can use another kind of modeling, which is networks modeling. So networks, they're related to complex systems. Networks is just, relate like elements with relationships to each other, and they could impact each other. So I just give you some examples of um, applications of network modeling. So this one is from Barabashi, and oops, people sort of that. Okay, what you're seeing here are all the proteins in the human body. So they mapped out and how they're related to each other. Now, um, the red ones are the proteins that the new coronavirus attack. How is this helpful, right? It's helpful because if you're able to see the neighboring proteins, so for example, if the coronavirus attacks this protein, you'll now be able to see the neighboring proteins, and you can check which kinds of diseases or which organs or tissues or cells or whatever are related to that protein, and so you can have like an idea of the possible impacts of COVID. Now they're using this to find drugs for COVID. So they're using network science for that. Here's another one. So this is in the context of the power grid. So what they did here is they mapped out the French power grid and as a network. So they mapped it out as a network. Looks like this. And then what they did was they wanted to check for vulnerabilities. So they wanted to see which transformers or substations, etc., are most critical to the network. That we have to ensure that these parts of the network of the power grid are working. Otherwise, it could cause a failure in a large part of the grid. So the way they're able to do that is they use network science, and they're able to see the most critical ones. So what they did is they removed certain like elements or nodes. So you can see here the fraction of nodes they removed, like 5%, 10%. And then this one is the capacity of the largest network in the grid. So if you let's say remove like 5%, some of the parts of your network will be detached from your main. Like what it's talking about here is the giant component from the main network, the largest network. Now they wanted to see how will the giant part of this network be affected if you remove certain um, parts of your power grid. And they were able to find some insights there using network science. So this is a really beautiful video I got from Nature. And this one is where they tried to predict which ecosystems are most vulnerable using network science. So let's just watch this.
To live on Earth is to live as part of a network. A giant web where almost every creature depends on others for survival. These networks are so complex that it's difficult to predict how resilient they might be to changing conditions. Let's take an ecosystem in Australia, where certain plants have a symbiotic relationship with various ants. The ants act as bodyguards protecting the plants, who in return provide food and shelter for the ants. But it's not like every kind of plant has its own species of ant. That would be much too easy. In fact, each ant can visit a variety of plants, and each plant benefits from the protection of a number of different kinds of ant. You can see how quickly a network becomes very complicated. Let's take all the plants in the ecosystem and draw a up to a point. As we remove ant species at random one by one, the connections in the network grow weaker and start to disappear. As we go along, as well as losing whole plant species, the abundance of remaining species gradually decreases as well. There comes a key point for every network where the population of the remaining species suddenly crashes. The network can no longer compensate for further changes. Where this point comes represents the network's resilience. This resilience is usually thought to be completely unpredictable, as it varies so much between different networks. But researchers have developed a new tool to try and simplify things. They started with complex multidimensional networks, all with different properties. The clever part is then using various mathematical techniques to transform all these networks into a standard model, in which the crash is always in the same place. This means that the resilience of the original networks is now predictable. This can be useful in predicting how ecosystems might react to environmental changes. Climate change, for example, can affect all species in a network and their relationships, weakening the strength of all the connections. This can make the resilience of a network so low that it might only take the removal of a handful of species to bring about complete collapse. This is particularly worrying for already fragile ecosystems, in which a tiny change could cause the extinction of a whole host of plants and animals. That's why it's important to have tools to predict and prevent these catastrophic network failures, like the disappearance of honeybees or unexpected collapses in commercial fisheries. And these models don't just apply to ecological systems. The same tools can be used to examine networks of people, from social networks to the spread of epidemics, banking networks in a financial crisis, and even networks of air traffic, in which a single problem could cause huge delays. Models of all these things are often available already, based on specific real-world data, but these new mathematical tools can be applied generally to a whole range of different systems. They should allow us to predict how any network will respond to change, and could even suggest specific strategies for preventing catastrophic damage. Whether it's plants, planes, or people, we may be a little closer to understanding the giant, complex networks of our planet.
All right. Yeah, so trying to predict vulnerable ecosystems using networks, that's cool and useful, super important nowadays. Okay, so let's recap in a nutshell. Um, Data science is about converting data into insights and action. Data science is the field that's about turning data into actionable insights or apps to achieve goals. Recap, we discussed what data science is, We discussed some data science frameworks. We explained the data analytics maturity. Um, we explained one framework from the business problem to the deployment. And finally, we discussed components of data science like math, statistics. You have programming, data visualization, but we focused on modeling. Right. Just some tips if you want to venture into data science. Definitely brush up on coding skills. Python, R, etc. Brush up on mathematics, but definitely have fun learning. Like, it doesn't make sense to do something that you don't like doing. Okay. You can learn faster if you have fun learning, and you have to learn fast. Data science evolves very quickly. Like, there's new tools almost every day. And some references, you can just search Google, O'Reilly Data Science, and this is gonna give you a bunch of books. Sorry about that. But yeah, you'll be able to see these books over here, and some more references. Some of the things that I've used, at least, think Python, DataCamp, Coursera, EDX. Can check those out. Right. So that's for data science. Now I also want to spend the time to showcase one of the projects we're working on, and it's Project Moses. It says here COVID-19 Crisis Response Toolbox. So we put quite a lot of features into this platform, and we hope that more people use it, and also we'd like to gather feedback about this platform. So just want to show a quick video of what it is about. All right. Yeah. So just stop sharing, and I'll share a quick demo. Let's see. Uh, yep. I'll share a quick demo of the app, and there we go. Right. Yeah. So this is the web platform that we're working on, and it's got quite a lot of features. The features have been summarized now in the video. But first thing is, uh, yeah, we have a self-triage system that we're working on. So people can use this to make quick, um, like diagnosis, not diagnosis, but like assessment. Yeah, assessment, um, whether or not they're a person under monitoring, person under investigation, and so on. So you can click like certain symptoms and so forth. And at the end of this, it's gonna give you like an assessment. Then, like we have a hospital directory. So, for example, I want to know St. Luke's. You can find it here. And we have a way to connect with the hospital so they can share their information. And you'll be able to see if they're requesting for supplies, accepting patients for testing, and so forth. But right now, you can see their address and some contact details. Right. So if I click that, it's gonna give me some statistics. However, there are no statistics yet. So yeah, we need to connect with the hospitals for that. However, what you can use right now will be the citizens patrol. Okay, so for example, you'd like to okay, for example, you'd like to share if a certain clinic, grocery store, pharmacy, or road is closed or open, or any information you'd like to share about these things. You can submit a citizens report, and you can submit like the name of the clinic, the address of the clinic, the contact details of the clinic, is it operational, operating hours, whether or not it does minor surgery, and all these information. And what we hope to accomplish is, if we crowdsource this information, we'll have some sort of directory of the different clinics, grocery stores, pharmacy, and road. Because as we discussed earlier, like the first step of data science is really data collection. So without data, you can't really do data science. So we're really starting with that. Yeah, and you can submit a citizens report. So it works more or less like a Wikipedia, that you can edit whatever's posted in the citizens report. And um, hope that this could be useful if we have lots of information. So if there's something you'd like to share, you can check this out in the citizens report. Now the website is just projectmoses.ph, so you can just check it out now. Now we're also collecting and organizing government announcements. So if you want a single place where you'd like to see all the government announcements, you can check it here. You can check the date, the source, and the announcement. But we also have a news aggregator. And here we check all the RSS feeds of, there you go, of news sites. And you see like Central Visayas, and these are news related to COVID and the quarantine. So if you want to see like a one-stop shop for different news sites, you can check it here. And we also have an archive of official statements. So these are Google Drive folders that you can check. So these are the raw like PDFs from the government. Then frequently asked questions. So what we did was we aggregated frequently asked questions about COVID, like what is COVID, what's the difference between COVID and SARS. So we want a single repo for all this information. Like instead of everyone going to Google and searching for these things over and over again, you can just check it here. What's a pandemic, what's social distancing, and all that. Then we also have emerging research, but we have yet to put information here. But what we want is it's like a single repo for all the emerging like studies, like research about COVID. Then you can also check useful links. So we have here the national government website. They do have this. If you haven't checked, they have Laging Handa website, Department of Health, Foreign Affairs. There you go. And COVID-19 apps. So as you know, there's a lot of apps being developed, and it's kind of hard to keep track of them. So what we do is we just check all of them and then see what's new, what they are, what they do, and then we try to organize them in a single place. So if you're interested in the kinds of apps that have been developed for COVID, you can check it here. For example, um, like dashboards, you have these things. There are other self-assessment tools that you could use. Even if we have a self-assessment tool already incorporated in the platform, you can try to use other ones. There are mobile applications and all sorts of things. If you would like to donate, you can check here. And yeah, and we also show the Department of Health dashboard here, as well as a Johns Hopkins University Interactive dashboard. But again, some of the dashboards can also be found in the COVID-19 apps. So there's one dashboard that I particularly like, which is the one from UP. I think it's this one. Yeah, this one. So ncov.ph. Yeah, we shared it here as well. This is a particularly useful one. Right. That's about it so far. We're continuously improving this and adding new features, but it would be great if you like to be proactive about it. You want to share some information about clinics, pharmacies nearby. You can submit a citizens report now, or if you're interested to find about hospitals, hospitals around, for example, Makati. Right, you can. Sorry, that's my name there. Yeah, you can check it out, and you'll be able to see the contact details and all that. Yep, that's Project Moses. Right.
Okay. Yeah, Prince, can you hear me?
Yep.
Okay, so thank you so much for that. So that was Prince Javier on data science and Project Moses. And Project Moses is very interesting because it's a one-stop shop that you can get all the information you need about COVID-19 to keep yourself updated. And I think that's very, very important now. And I think that's also the motivation of Project Moses, right, Prince,
Yep.
to give everyone access to information from different platforms, not just from one news outlet, but from all the most reliable news outlets out there. So before we also go to the questions, I would like to encourage everyone to send in their questions by leaving a comment below. So just leave your comments there, are your questions there, and we will answer them in a bit. And yeah, we'll give Prince a little bit more time to prep up for your questions. And I think we have a few questions already. So for those questions that we will not be able to answer tonight, rest assured we will contact you through email to give you the best answer we can find for that. Of course, that would be just Prince, not me. Prince will give you the answer for those questions. And just to remind everyone, this episode is the session is powered by recruitday.com, and kickstart your career today by scanning the QR code on your screen, and you can also use the link in the comments. And if you're a fresh grad or a career shifter and you want to pursue a career in IT, recruitday.com can help you find jobs in awesome companies even during the crisis. Just visit the link to apply, and you can also refer friends and get 3,000 pesos if they are hired. Okay, and additionally, since we are also promoting continuous learning, okay, so join our first ever bootcamp this coming June and learn the fundamentals of Salesforce development This free 4-hour crash course will introduce you to skills needed to become a Salesforce developer. So, limited slots only. So, grab this opportunity now and register the free for this free online training through the link provided. And I think there's also a QR there that you can scan. And again, this session is powered by recruitday.com. Kickstart your IT career today by scanning the QR code on your screen right there. Okay, so let me just browse through the questions now. I think we have a few. Okay, Prince, are you ready for the questions?
Sure.
So walang prep time to, no? I'm just gonna
All right.
flash it on screen and I'm gonna read them as well. Okay, so I'm just gonna sift through these. Okay, here's one. So from Jerome Makabanti, hi Prince, this is G from Sydney. How is data science different from data analytics?
Hi, Jay. Um. All right. I'm not sure. The thing is, there's a lot of overlaps, right? Does data analytics involve coming up with web data applications? If data analytics, because my understanding of data analytics is it's about getting insights out of data. Sure, that's a bulk of what data science is about, but I'm not sure if coming up with deployable applications, data applications, can be considered as part of data analytics. So if it's not, then I think that's how data science is different from data analytics.
Okay, thank you for that. And for Jerome, if you're still listening, you can still do a follow up question by leaving a comment. And if we have time, we can definitely answer that. And we have another question here from Dario Vallejos. So he's watching us on YouTube. Will it be correct to say that creating a principal component biplot would fall under descriptive descriptive analytics, and then by adding loading arrows, it becomes a form of diagnostic analytics?
Right. Okay. Principal component biplots. Uh, see, the thing is, descriptive analytics, it's about trying to practically just describe the data you have. Um, okay, while diagnostic is trying to see why. Why is my data like this? Okay, so if your goal is to answer why, then it becomes diagnostic analytics. So if you have like a scatter plot of your data, and then you kind of compressed your data into two principal components. Okay, principal component analysis being a way to, in a way, um, summarize your data set. Okay, so if you have a lot of columns, you can probably summarize most of these columns into just two columns. So that's what principal component analysis does. Now, if you only have two columns, you can now plot it on a 2D plane. So you have a scatter plot there. That, in a way, is descriptive analytics. You're able to see um, how your data looks like if you plot it on just two principal components. All right. Now, if you put loading arrows, what you want to see there kasi is what particular column in my original data set influences the first principal component, the second principal component. So each principal component is a combination of the different columns we have. Okay, it's a combination of those. So you just want to see which influences which. So what question could you have that's a why question that plotting arrows can answer? If you're able to answer a why by plotting arrows, then it's a diagnostic analytics. But if you're not able to answer why, it becomes a descriptive analytics. Maybe your question is, um, what what are the drivers of one particular principal component? Like, what are the main factors that are incorporated into that principal component? But it doesn't. I would think na it doesn't really answer a particular why. So personally, I'm leaning to say that just plotting loading arrows, that's still descriptive analytics, unless you have a question that involves why your data behaves a certain way, like your particular data. Why does your data act like that? Then it becomes diagnostic analytics.
Okay, thank you for that, Prince. And for Dario, if you have a follow up question, you can just leave it in the comment section. And if you don't answer it tonight, we'll definitely answer that through email. So I guess we have another question from, well, I'll ask you this one, Prince, from Dario. It's obvious that Dario is, I think, studying data science, if not a practitioner. So, question number two for this is part one. How would you enhance the explainability of a random forest model? I came up with a random forest model kasi using scikit-learn, but I was told that it is a black box approach. And part two, being a black box model, it may be accurate, but it makes the outcome less explainable. So I'm not sure if that makes sense to you, Prince, because it definitely does not make sense to me.
All right, so random forest, it's a machine learning model that's made up of several decision trees. That's why it's called random. That's why it's called forest, because it's made up of several decision trees. And a decision tree, it's like a what do you call this? It's a series of yes no questions. Okay, and it's a branching yes no. It's a branching yes no questions. I'm not sure if I'm making sense, but it's my example before. Na, do you have whiskers? Yes or no? Yes. Do you have four legs? Yes or no? Yes. Then you're a cat. So that's a decision tree. Now, if you have a lot of those decision trees, you come up with a forest. Now, the question is, how do you make the forest um, explainable? The thing with decision trees is they're really explainable. Each decision tree is easily explained because it's just like, an example like if else. So what a decision tree machine learning model does is just figures out the question to ask, and then basically that's it. It just figures out what question to ask per each stage in that tree. Okay, so it's a tree because you put a lot of branches. So you start with the first question, it branches out. Next layer of question, it branches out. It's really explainable. The question is, if you add a lot of decision trees and they kind of do not share the same questions, the same set of questions, and some even contradict each other, like how do you identify that? Well, you can like average them out, So if one question asks like, okay, let's say the question is, are you 6 feet tall or are you 5 feet tall? Okay, you can just average them out somehow, very loosely speaking. And I think scikit-learn has that capability of averaging them out, trying to come up with the metrics that they have metrics there with integrated in scikit-learn, like feature importance metrics. I think they're using Gini index or things like that. But there's a way that you can aggregate them. So another like intuitive way of looking at it is how many times a particular question comes up. So if you have a decision tree, does it have whiskers? Your second decision tree, does it have whiskers? And your third decision tree, does it have whiskers? Chances are having whiskers is an important like feature. Okay. But if it's just one decision tree out of like 1,000 decision trees that asks, does it have a whisker? Then chances are having a whisker isn't really that important. And I think there are like integrated features in sklearn to do that. However, you can also use external tools for that. There are external explanation tools. For example, SHAP. You can use SHAP. The thing with SHAP is, Okay, SHAP is just an external tool, and it's just a way for you to see how one factor influences the outcome. So if you have 100 factors, it does some sort of sensitivity analysis, remove one factor, add one factor, let's see how it changes the outcome. And there's a SHAP value for that. They calculate the importance using that approach, very loosely speaking, because that's not exactly how it works, but that's the intuition behind it. You can use that for even neural networks. Okay, so one way to reduce the black boxiness is you don't necessarily unpack the box. What you can do is just look out the outcome, change the input, look at the outcome, change the input, look at the outcome. So it's like a sensitivity analysis of sorts. However, there are some groups that actually unpack the neural network. Like in particular, neural network for images. Right? So if you're familiar with convolutional neural networks, you can literally unpack that and see how each layer looks like. There are people who do that. But for the most part, scikit-learn's internal internal feature importances should work, as well as using tools like SHAP to see the important features. Yep.
Okay, thank you so much, Prince, and I hope that answers your question, Dario. And Dario was able to give us a little bit of context around that, and I'll message that to you, Prince. And also, Dario, you can always get in touch with Prince through LinkedIn. Yeah. And also, if you have other questions, you can always leave that in the comment section as well. And we'll try to answer that through email offline. So I think that's it. Let me just try to see if there are a few more questions. So let me just read this one out. I think this is very interesting. So Javier says, Project Most is a very good web dashboard. It's a good help to all Filipinos. Are you
Yes.
related to just...
Yeah. Tita. Yeah, si Tita. Thanks, Tita.
Yeah. Yeah, okay.
Yep.
Yeah, so thank you so much for your time, Prince. That's all the time we have tonight. And guys, just reminding everyone that next week we will have Paulo Espiritu and Argelo to talk about Haraya Learning Innovations, the future of learning, a little bit about AR, and also paginated reports using Power BI. So that's next Saturday, same time, 5 p.m. to 8:30 p.m. So it's back to back, and we'll be using the same platform as well. So don't forget, guys, to subscribe to our YouTube channel so that you get updated on new content. We'll try to compress all the online video recordings into a short video so that you can watch it again very easily. And for those who'd like to get the session packs, which will include the presentation and all the references of tonight's talk, kindly register using the link in the comment section of this video. And again, this episode is powered by recruitday.com. Thank you so much, Prince. And guys, don't forget also to visit projectmoses.ph. So it's a very important platform in getting yourself well informed in what's happening in the world today, at least for COVID-19. So thank you so much, Prince. And everyone, thank you so much for tuning in. See you next Saturday. Have a great day.
Thank you.
Okay, bye, Prince.
Bye, Luis.